Welcome to another community meetup. So super excited to talk today, diving into some coffee here. We just went through the holidays, which was great. So hopefully you guys all had good holidays. And we're going to talk today a little bit of a reflection on 2025. We're going to talk about 2026, what we got planned, some of the goals, because this is how we set up. Even before that January 1st starts, we got to start talking about what we're going to do for 12 months. 24 months, 36 months on where you want to be in your career. So we're going to dive into that. Then we're going to get into some technical stuff like we always do. We'll get into some, hey, Nikki, we'll get into some case wiring. We're going to talk about some defrost heaters, how to replace them, some technical side. But I think it's really important to really set yourself up for 2026, because this is what we did a year ago. And the time just keeps going by. But we want to set ourselves up and prepare ourselves for the year ahead, and a lot of people wait. Oh, I'm waiting for January 1st to start the gym. I'm waiting for January 1st to start my New Year's resolution. It doesn't matter if it's the middle of July. You should be working on these as well. But we're going to want to talk about 2026, what we got planned. Andrew, how you doing, brother?
Oh, fantastic. I got my coffee. I got to talk about refrigeration. Get to meet up with every one of you guys. I am ready. I'm ready for today. Let's go.
Yeah, I love it. Noah, welcome, my friend. Welcome. Good to see you again. Okay, so let's dive in. For 2025 has been a great year for me personally, great year for Refrigeration Mentor. And a lot of it was planning at the end of like in 2024, 2023, planning the steps on the things that I wanted to do, wanted to accomplish. Some of the things for me was talking on some of the biggest refrigeration stage. I did my biggest keynote this year and talked in front of hundreds and hundreds and hundreds of people. And that's one of many things. I've talked at dozens of events. I've done dozens and dozens of podcasts. I've trained thousands of technicians all around the world, which is huge for me. And I continue to hit these goals because I set them. Did I hit all of them? No, I definitely did not. Am I upset about some of them? Well, I'm not upset, but I'm like, I need to. I need to work harder next year to hit those goals, those personal goals, financial goals, health goals, whatever they are, and just really step up. What are some of the things that you feel like you accomplished in 2025, Andrew? Because I know there's a ton of them. The list goes on for you.
Well, the biggest thing was I knew I wanted more CO2, so I made a plan is to get into more of that. And I ended up moving a couple states south to achieve this goal. Really, I knew I liked it. And then now that I'm where I'm at now, I mean, talking with the boss, switching bosses, really moving locations. I mean, it was a big, it was scary. I'm not going to lie. I just like, well, let's do this. And it was honestly like 2-3 weeks later that I made that move when I finally told my bosses what I wanted to do and talked with the other boss down here. And so that was my biggest achievement, I guess I would say, was moving to do more CO2. And then ever since then, I just been proving myself down here with my crew. And then now I ended up getting exactly what I wanted, which is the EMS type of things. So I'm doing all of that. And I just got told probably a couple months ago that I'm actually going to do my first startup brand new store for a store. So I'm really excited for that one. That's they're building the store right now. I'm ready. So I'm really looking forward to that one.
Yeah, and I know you put a lot of hard work, and we talked about this on the podcast before. If you want to get and achieve the things you want, you have to put the work and you have to put the time in, and you have to do things that are uncomfortable. Moving 3 or 4 states is not easy. I've done it. You know what I mean? I moved different province. I've moved across the country to get a job before. So I know how you feel. I've done it. And it's not easy. But look where you're at now. We talked about over a year ago, you wanted to get more CO2, well over a year ago before this even happened. So it wasn't like it just happened overnight. We were talking about this for a long time. You talked about you wanted to get an EMS well over a year ago. Me and you've been talking about it for a long time. You've been telling me I want to get in this area. And what did you keep doing? You just keep plugging away. You've seen the goals that you want. You told people the goals you want. It didn't happen right away. You know what I mean? It didn't happen. It wasn't like, okay, here's the job, Andrew. You just kept working for it, proving yourself, doing the hard work. And even when you probably deserved it a long time ago, you still just plugged away. You didn't stop. And then now it's starting to happen, which is great. And this is how you make things happen. You have to change yourself. You can't change anyone. You got to change yourself. Even when there's a setback, or you got to go, you know what I mean? Or it feels like you're going 2 or 3 steps back before you can get ahead. And this happens, but you just don't give up. And that's something you didn't do all year. And you pushed harder and harder and harder. And now you're starting to reap those rewards.
Yeah, I think what you just said there, what you just nailed it, is saying exactly what you want. And you gotta be willing to, prove yourself and endure the what you're doing already. So I don't see that being an issue. But the issue when I first started was I had a problem, I guess, saying exactly what I wanted. I don't know. I was nervous. I don't know what the whole reason was. Maybe I was just worried about I wasn't ready for it, so I didn't really speak up. But now I know today, if I want something, I'm going to say it and have a plan on how to get that too. But that's this, part of knowledge and growing up and figuring out exactly how to achieve goals and stuff. So it's just, experience is how that really works. But now that I know that, oh yeah, I'm chasing it now. So yeah, I'm definitely pushing. So.
But that's a big thing, though. Like, you wrote this stuff down, you said it, you wrote it down, you planned it. It's not, it doesn't, it's like, I remember when I used to work at Copeland, and I took a massive pay cut to get the job. And then every year, like, I wanted a bigger pay raise. And you know what I mean? They're a corporation. They're not just going to fork out they just can't, you know what I mean? But it's like, I just kept asking for it and asking for it. And I was proving it. And then I was asking for it and proving it. And at the end of it, when I left it, they offered me what I wanted. I finally got to the point, because I proved it, I did it, and I got to a point where they made that offer that I was like, holy smokes! It might have took me 7 years to get to what I want, but I made it to that point. I switched directions, and I started Refrigeration Mentor. But I put that work in, and it might take you 7 years to get what you want, or 5 years, and because today we always feel like it's taking too long because it's instant gratification, but sometimes it takes a long time. And 7 years is not that long, because it goes by just like this. You know what I mean? Like, it's going to go by anyway. If you're working towards the things that you want, that's where things will happen. And make sure I try to make sure that I'm working towards the things that I want. Does things change along the way? 100%. But when you have those goals written down, like, I wanted to train tens of thousands of people, I want to be one of the top speakers in the world on refrigeration. This stuff is happening. You know what I mean? I'm working there. I'm moving up the ladder. Maybe it'll take another 5 years. I don't know, but I'm not giving up. I'm not giving up. I'm keeping pushing forward. What are some of your goals for 2026, Andrew? What's some of your plans coming up?
Well, so there is some movement on just really focusing. What I really want to do is just nothing but CO2. So I mentioned a little bit earlier today is I'm going to be part of the startup crew. So I'm actually integrating my career into not just only service, but I'm actually getting into that install portion of it too. So I'm going to be bouncing around kind of all over the place as far as CO2 goes. So yeah, I'm going to probably be that startup tech. Right now, like I said, I got the drive, and that's what I want, and I made it known that that's what I want. So I've been kind of going around all the other CO2 locations and pulling up graphs and seeing things and smoothing things out. If you follow me on the community, you'll see that I do post some of that stuff on there. And then also on LinkedIn, so you could actually see the changes that are happening here. And Erik, I got to give a shout out to Erik and you too, Trevor, that you guys really helped me guide me into a spot where I can make those graphs look amazing. So I appreciate you both on that aspect. Yeah.
Yeah, and that's it. It's putting in the work, learning, continuing to invest in yourself, and that's really what we do here in the community: is invest in all of you. Refrigerationmentor.com/hub for those who just listen on the podcast. But what Andrew does day in, day out is in the community is trying to help all of you, and the more he can help and share that knowledge, the more it helps him grow. And it's just like Erik sharing his knowledge with all of us, because he's been doing CO2 for decades now and has epic amount of knowledge on CO2, but just sharing those little tips, and then you get to hear it over and over and over again. That's one of my goals for 2026 is like, I've been doing CO2 for over a decade now, training it since 2015, 2016. And I'm going once again all in this year to really help more technicians level up in CO2, more advanced refrigeration on controls. We got a supermarket school coming out. I'm so pumped up about this, though. So we're doing a full school for technicians. And now this is going to take a technician really to the next level of their career, or if they're just starting out in their career, to take them to where it's not going to take them 10 years to get where it took me to get 10 years. And this is one of my goals, is to help technicians, to help companies fast track their team, to really help them have that confidence, that speed of execution, that really reliable technicians. Because one of the big things that I see in the industry today is that there is a lot of not callbacks, but there's a lot of issues just on regular service calls, that there are cases continuing to freeze up. TX valves, like when you go into the store, there was one time, I think maybe it was in August, you're like, Trevor, I just walked around the store, I took 14 pictures of TX valves. I don't know if you remember this, Andrew. And 14 or 15, you weren't even on that call, and you were just looking into cases, because this is what you do. You walk around, you're not even on that call, and 14. There's probably, I don't know how many cases in the store, maybe 50 or 100, but 14 of them were plugged. They're like, well, this is a suspect. This is a suspect. This is a suspect. And that there is lack of maintenance, lack of intuition, not intuition, but lack of that over and above, going above and beyond of what you really need to do. Because you had nothing to do with that service call. And I think there's 3 or 4 times last year that you reached out. It had nothing to do with the service call, but you saved that customer thousands and thousands of dollars. Kind of like that CO2 story with that apprentice.
Yeah, I mean, it's just when I was going into this career choice at the beginning of my, I was following a technician around, and things get busy. I totally understand, but it was kind of walking in with blinders. Like, I only go in right to what I need to do and get right out. And now I realize, like, man, we're not doing us justice. We're not doing the on-call person justice. We're not doing the customer justice. So it just makes me like rethink everything. And then again, that just comes with experience. At that time, I was just trying to figure out maybe what a TXV actually truly does, So there's those levels. But as you start to level up, man, level yourself up too. What can make you a better technician, right? So that's kind of how I took that. And that's kind of been my theme, I guess, is like, how can I do better than what I am now? And that's one of the reasons that I keep pushing, because I know I can. I just what and speaking of that, going in and just the customer don't know. I mean, they stack items in and customers grab them out. That's their job. Our job is to take care of them, which is take care of their equipment. So if we see something, say something. I mean, or hear anything, just use all your senses. Maybe it's a smell, I recently, I think I posted it on the community. I was helping one of my fellow technicians out, and he was like, "Man, there's no refrigerant in here," and he threw nitrogen in it, and he's like, "I can't find the leak." And I was looking, and I thought I saw it, so I stuck my head down there, and I could actually smell it. So it's just, it's just those things that what you kind of pick up over the years, and it's just let that be your guide. Just keep pushing.
Yeah.
That makes sense. So yeah.
Yeah, and I think that's the big thing is that a lot of this does come into experience when you're first starting out. Is you don't have a coach, you don't have a mentor, and I think there's still not enough. That's something that you do really well, Andrew. Something that I believe I do really well, and a lot of people in the community, Erik, Steven, Noah, we all do a great job at coaching, and coaching is different for everyone. You know what I mean? It could be just teaching, not only teaching, but giving advice on how to change a TX screen. Okay, it could be giving advice on how to put the meter on a compressor to properly ohm it out. Not doing for it, but just coaching them along the way. And I think this is one of the big things that is missing in the industry: teaching versus coaching versus mentoring. And there's different avenues about it. And I think all three of them plays a role into really developing a new technician to the industry. And the more and more that I teach people, and I see people in the community, and I see people outside the community now, kind of more coaching people and helping them along the way instead of just doing it. Because I hear a lot of that, especially from the younger technicians in the community. Oh, I've been riding around with this person, but they're actually just doing the work because they want to just finish the job and go home. And I totally understand of those experience. They've been doing it for 15, 20 years. They want to get the job done and go home. But you've been doing it for 20 years and you spend the time to actually coach them. Andrew, I want to talk just a little bit about that because there's quite a few videos. For example, the CO₂ Westermeyer video where you teach how to change the oil separator. What's the difference when you're doing coaching to an apprentice? Because you don't just do it and get it done and just over with. What are some of your process? Give a couple of tips when you have an apprentice there and you're coaching them on a specific task.
Yeah, so depending on the level of the apprentice, it's so I kind of gauge on that. So if they're really brand new into the field of refrigeration, I just let them know the steps. Like this is how we're going to do it, and here's why, and then let me show you now. If they're next level or they know kind of what's going on, I say, okay, now I want to know how you're going to tackle this. Thing how we're going to do this, so I let them explain it to me and their thought process, and then I just go from there. And then if it's and then I let them do it, and I'm just there just to make sure, I guess, everything goes smoothly, safely. So really that's all that I do. But I want them, really, to me what's important is I want to know what they're thinking, and then I could guide them from there. So as far as when I first started out, and that support that you talked about, that's huge. I think that really guides a lot of technicians coming into the trade. It's really going to guide them and, like you said, fast track them into it. But there's a lack of it, and I felt like when I came through, I needed more mentorship, and that's where it wasn't. And if I had that, like a person, I guess you could say, I think I would have been even further than where I am now. But I also learned a lot too, and I can't take that for granted either. So, but going back to your question, as far as getting the apprentice more involved in it, I already know how to do it. I want them to learn, because if they know how to do it, now I don't have to be going back or questioning or wondering. It's all taken care of because I know he knows how, or she knows how to do it. So that to me is the win in all aspects.
No, and I totally agree with that. And it's like, how do we make the industry better? We make the industry better by sharing the knowledge, helping others, bringing value to more people in the industry. I had a lot of conversations with people where they're like, "Oh, a lot of these techs are holding it close to their chest. They don't want to share. They don't want to spend the extra 10 minutes." And there's going to be a lot of people out there like that. But you want to find the people that, like Andrew, like Erik, that want to spend that extra time. I know tons of people in the industry. I can name countless different manufacturers, countless different contractors, countless different technicians who are willing to spend that extra 10 minutes because they care. They care about teaching that. They're looking for people who want to learn. I think that's one of the biggest things today. Now I'm noticing they're looking and trying to find more people who want to learn or are willing to learn because they know the value of sharing that knowledge.
Yeah, staying curious is huge in this trade. I mean, and it goes a long way. I connected with Jacob. He might be on here. I don't know. And he's a go-getter. I love that. I see that, and it just, for me, it's just like, if you want to learn, here's this information. Let me give it to you. You know what I mean? So if you are that person, you want to learn, ask. Just like we said at the beginning of this podcast, we talked about asking. I mean, that's right there, is ask those questions. I guarantee that person that you're following or you're with or whatever had those same exact questions back when they first started. And it's not, just ask the question. That's to me is kind of a struggle point with my apprentices now, is that, and it's not necessarily that they don't ask the question. Sometimes they don't even know what to ask. So that it's a tough balance. And sometimes I get to that point where I'm talking so technical that I have to pause and think about what's really going on here. What questions do I really need to ask? But if you're just spitfiring stuff, it's kind of hard. So research. I mean, go home, 15 minutes a day, research that part that you might have no clue about and you don't know what to ask. And that there is going to be a huge game changer. 15 minutes a day.
Yeah, I totally agree. And that's why we talk about this stuff in the community all the time, is investing in yourself. And that's how we continue to evolve and grow, is investing in ourselves. And I think 2026, if you spend that 15 minutes, like Andrew says, 20 minutes a day, which is not a lot of time. That's less time than you're spending just scrolling through your phone or Instagram feed or Facebook or LinkedIn or whatever, Netflix. 15 minutes a day, specific topics that you want to learn. And I think writing those down, I think I did this a few years ago. I still kind of do this, and I will do it this year on all the podcasts that I'm planning out and the trainings that I'm planning to do with other people, is that write down what you want to learn. So if I want to be better at, say, the high pressure valve, well, write that down. Next week, I'm going to just learn the high pressure valve. Well, I know I work on Danfoss. I know I work on microthermal, and I know I work on Copeland. So then all of a sudden you're like, okay, if I'm going to look at it that week, go do some research. Okay, pull up the Danfoss manuals, pull up the microthermal manuals, pull up the Copeland manuals, search just a high pressure valve, go online. I got tons of these videos. You could just go on the Refrigeration Mentor YouTube channel and probably find tons of them to get you started. But that's it. And then write it down, make that list, because you're going to forget. If you don't make the list, you're going to forget. Because I used to think about stuff. Oh, this is a great idea. I want to try this. I want to get this person on the podcast, and I want to do this. If I didn't write down, I would forget, because there's just so much stuff going on. You can't remember all of it, because we're in a trade that there's 1,000 different components in a transcritical CO2 system. You know what I mean? Or different things that you need to do. Refrigeration, supermarket. So it's so important. Andrew, I think.
Yeah,
go ahead.
Another, I guess, tip that I would like to say is find out the equipment and know what it is running correctly. So if you know exactly what's supposed to happen, even if it's a sequence or what it's supposed to be doing right now, you're going to know when something's wrong. So, I mean, there's been plenty of times where the day's done and I just sit inside a machine room and just pull up graphs. I mean, especially right now with me going into that EMS and trying to smooth everything out as far as the graphs go. I mean, there's been countless of hours where I just sit in the machine room and just tweak or just turn things or slow things down or speed things up just to follow it and watch it. So I mean that's where I'm at, is sitting in a machine room and just going through and checking things, and that is all on me. That I'm not charging the customer, I'm not charging my company. I that's for my personal developed. So I'm constantly pushing learning, and then I love to share with what we talked about with you guys of my findings and what I do, just so because I just know it's going to help you guys, right? But that's how you could help yourself, is spending the time like that 15 minutes after work, or pulling up graphs or whatever you're going to be doing. Prime example right here. This unit was banging on and off, and then I make an adjustment, and you could see on that graph where that line is almost just smooth as it can be. And that's just barely doing it right there. So,
yeah. So
anyways,
those that are listening on the podcast, we're looking at the air cooled gas cooler. So this is the condenser graph that we're looking at, and this would be the
drop leg temp.
Yeah, the drop leg temp. Okay. So how did you recognize this? Andrew, first of all, what were you doing to get to this point? Was it a service call, or were you just looking up trend graphs?
So the heat reclaim unit wasn't working on this store, this unit here, and so I was getting that heat reclaim up and running perfectly, and then I decided, since I'm already there, I might as well look at all the graphs and see what I can do to help make this thing run smoother. And investing in myself, putting the time in and doing the podcast here and talking about refrigeration, this is kind of where I learned, like, this isn't normal. And anything ramping up and down should, that should be like hey, there's something might be wrong here. Let's figure out what's going on. Of course, do your basics, make sure you got full liquid charge, make sure all fans are running, make sure, everything is running as smoothly as possible with the visual eye and listening. And then after that's where I made these adjustments here. And I think the ramp speed was at 2,000 increase and decrease on this one. And then I dropped it down to 200. And man, it just smoothed right out. But what it was doing, it was ramping way high, and that's where that spike is on that graph on top. So the fans came on, started really coming on, and then slowing down, and then it would slow down too much, and then the drop leg. And so it's just, there's no control. It's just trying to maintain 80 in this aspect, but it was just overshooting and undershooting because the fans were reacting too fast. So I just slowed those fans down, and man, and then it just smoothed right out almost instantly too. That was the craziest part.
Okay, so let's dive in a little bit deeper on it. So what drive was it? Do you remember the drive that, or the motors it was Zilabag? Was it MPAS? Do you remember the condenser fan motors on them?
No, okay. This was I just hooked up to the E3 on this case.
Okay.
So I didn't even look at the motors itself. I just went right to the programming.
And so then when you went into the program, you were looking at how the ramp speed works. So there's a specific range. Do you remember the range from what the speed could go from maximum to minimum?
No, I know it was 0, obviously, and then all the way up. So I think it could go numbers up and beyond, but the one that was there was 2,000. But through my career, I've seen it all the way up to 5,000 before.
Wow. Okay.
So I don't know if it can really ramp that fast. But it's something that I need to look into. That's a great question.
Yeah. No, but the thing is that, okay, all of a sudden the pressure, the temperature, drop leg temperatures, you can see here, those of you watching, the drop leg temperature starts to rise really quickly. We get way past 80, so we overshoot big time. So we're overshooting like from here to here. And then all of a sudden it's like, okay, let's ramp it up. So all those fans spin. So do you remember how many fans were? I guess you weren't up there. Or did you check how many fans? Is it a 4 fan or a 6 fan?
Yeah, this instance there was one, two, three, four fans,
Four
and it's
fans.
all in a singular line. It's not two fans side by sides.
Yeah, yeah.
Four
So
fans.
it's a four straight. So all of a sudden they're all ramping up and down together. So all of a sudden they turn, the pressure temperature goes up in your drop leg temperature. It's like, holy smokes, we gotta drop it down, and then bam, and then it overshoots again because they speed right up, and then all of a sudden we undershoot now, and then they slow right down, and then it's like, oh, now my drop leg pressure goes up. And so that one set point, we don't have it here, but I think in another one we'll show you in the community where the exact set points, because I can go look this up on the E3 program, what set point it is. And I would be right in here in the VS setup. Is that where you change it?
Yeah.
In that section right
Versus
there?
setup. Yep.
Yeah. So
Yep.
right
That's
there.
exactly where I click, and then you go down to um, it says something about increase
Ramps.
and decrease speed.
Yeah.
If I had it right in front of me, I could tell you, but yeah.
Yeah, no, that's totally fine. So, but then you went from this very large range, and we talked about this many times in the podcast. With CO2, you want to slow things down. It's not, you don't want to speed things up. You want to slow things down. Electronic valves, slow them down. High pressure valves, slow them down. You want to slow this stuff. There's a lot of moving parts with a CO2. And so when you change that, you can see instantly right here. Like, we're still undershooting a little bit, but this is only within 5 minutes,
Yeah. But
right
that's
after you.
how, yeah, that's how quick you notice the change as soon as you slowed down those fans, and how smooth it got. I couldn't believe it, and how quick it changed. I mean, it did overshoot a little bit after that change, going back a little bit, but it smoothed right out almost instantly. Oh
And
yeah.
here's another graph of it. So this is the valve percentage, maybe?
That is the valve percentage. What does it say? Is that the full picture there, Trevor?
Yep. For this one, there's
Okay,
another
so
picture as well.
that's going to be either the I think this is going to be your high pressure valve.
Here's the other one. So this is one, and then this is one. Right here. So I would say this.
Oh, valve two, that's our flash gas bypass.
Yeah. So let's go back.
Valve one, which is that one, that's my high pressure valve. So you can see where it slams all the way shut and then opens up and slams shut. It's just like there's no control, right?
So if you're looking at this, so this is 5, 15, 25, 35, 45, 55. So if you're listening on the podcast, it goes from 55% all the way to 0%. And you can see here, it goes all the way up and then all the way down and then all the way up. And like, if you've seen this, you'd be like, oh man, there's something wrong with the high pressure valve. You know what I mean? Over here, it's a little bit different, but I would say this is still hunting too, because we're going from almost 15% all the way up past 40%. So we got a massive, like, it's going up and down. So it was a little bit better right here. Do you know what I mean? But it gets real bad right over here the next day. And
yeah, and that's when it turns nighttime, and so the load drops off the rack, and then so at night it was doing that. So, but as you can see, during the day it was slamming. Well, I shouldn't say it was slamming, but there's really no control. I mean, it was going up and down, up and down, la, 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 la. It's just crazy. And yeah, like you said, you would think that there's something wrong with this high pressure valve. I didn't change a thing on that high pressure valve.
yeah,
That's the cool part.
and this is within, spending 15, 20 minutes taking a look at that. And we'd love to see the graphs today, you know what I mean? And then you can even fine tune this more, because one of the things that you said, the first thing that you said before all of this, well, is the coils clean? Is the fans all running? Is this you got enough refrigerant in the system? Like, just things like that. Just always all the basics. It doesn't matter the system. And then within a few minutes, you went from, going from 0 up to almost 55%. You're going from 45 to about 30. You know, and so you're going from a 50% to about 15% right about here. And that's just making one set point change.
Yeah, and that graph got tighter and it spread out further. So now you could see that it isn't consistent, but we're moving in the right direction, right? So that's the really cool. So I love it because you could see exactly how it's working and how quickly it changed just by changing the fan speeds on the condenser. It's remarkable to me. It's just crazy.
And then so you have fans not working properly. That fans affects your high pressure valve, then which affects your flash gas bypass valve or that receiver pressure valve. This is so key because these all work together. And now if you looked at this graph and be like, oh man, well, my flash gas bypass valve, it goes from 30 almost all the way up to 75. So we're opening and then we go down and closing, but it's probably not that. I would say it's probably going about a 25% on average, because those ones are the spikes. So I would say here, if we go over here, when you're looking at a graph, you look at these different areas, not only the spikes, but I would say probably about 20 to 25% open, close, open, close. And then it gets even bigger over here during the day. Like your range is probably going 30, over 30. And then when you did that set point change on that gas cool, here we go. We're about, say, 10% open and close, not even. So if we actually go from here to here, the top and the bottom on the standard one, not from the maximum, we're probably less than a 10%.
Yeah, it's huge change. And just like as we talked about earlier in a different podcast, and that was, you got to start from, if the fans are ramping up and down, going crazy, you have no control throughout the entire system. And I got to credit that towards Erik because he's the one that kind of mentioned that. And I took that information and ran with it, and it's just crazy the difference that happened here. So thank you, Erik, if you're still here. So
I'm still here. And you're absolutely right, Andrew. It's all about the circle, refrigeration circle, following that direction of flow. So figuring out just one place you can make stable. And in this case, with the CO2 system, the easiest part to make stable is the condenser gas cooler, because you could just set the fans to a fixed speed.
Yeah.
So, and then from that fixed speed, you can figure out if you could gain some stability in your system, and then you could figure out if it's the gas cooler that's the issue, or it's the high pressure valve, or whatever it is that is the issue. Because now you got stability at one point, and then therefore you should also get stability further down the chain.
Yeah, and it shows just right here. So love it. Yeah. I love it.
And that's the thing. And Erik has a good point there. It's like if you just went and put them all at 50%, the fans, and just ran them at 50% or 40% or wherever you can, what a good percentage on that ambient, because you got to think about what the temperature is outdoors, but you get it at a stable percentage. Those valves should start to, they shouldn't be bouncing all over the place, because if we got a constant airflow at that same temperature for say 10 minutes, that high pressure valve shouldn't be bouncing all over the place, or the flash gas bypass valve, unless potentially there's something going on with them, or something else in the system, like an EEV running into an issue where it opens up and it closes, open up and then closes, or multiple ones. So then this is where you get that baseline on what's going on. So that's a really, really good point, right? And it takes time for this, and you got to look at it. But you know what the biggest thing from this, Andrew, when you showed me and send this to me? This is no different than working on a standard supermarket system.
Yeah, true. If you got no stability, it's going to be doing the exact same thing. So it's just like you said, there's really no difference here. And
because if your condenser fans, just say you don't even have, you got one variable speed on the front, and then you got some fix, and one bangs on, and then it bangs off, and it bangs on, and it bangs off. What does that do to your drop leg temperature, drop leg pressure going into your A8 or your holdback valve, then going into your receiver, and then that receiver pressure going up and down, up and down, up and down. And so now my liquid pressure going out to all my TEVs, now that pressure goes up and down, up and down. The valve's not going to know what to do. It needs to be stable and consistent. Love that stuff. Love that stuff.
Yeah, and I noticed it's because I went to a CO₂ store and just messing around after hours on it just to see what I can do. I actually got in there and I slowed the ramp speed of the fans too much, and it actually ended up showing the exact same graph, basically just up and down because it was too slow to react. So just for you guys listening, make sure that you gotta fine tune it, and that's where you kind of just sit there and play with it until you do. So I noticed that as well when I was messing around with the fan speeds.
Yeah, love it.
And a good trick, if you are working with PRD systems, always only change one parameter. So only change the P, the I, or the D link. And usually, I recommend always doubling or halving the value. So if your stable is reacting too fast and too aggressive, then half the P value. Give it some time, see what happens. If that still is too much, half it again. Or you have to maybe go halfway up between those 2 points again. So it's always about halving or doubling the amount. Then that is the field version of fine tuning.
I haven't heard that before, so that's a good point. Because it'll give you some data right away. Instead of doing it a little bit, it might take a long time to see actually something change. But if you double it, it'll give you some data quite quickly.
You get a really quick response on the system, and you will have a feeling if it's the right direction.
Yeah, because all you have to do is put it back.
If you double it and it gets worse, then you just put it back again and half the value from there and see, okay, now we got more stability. So it could go either way. I couldn't tell you from the beginning if you have to double or you have to half, but just do one of the things and see what happens. Yeah. And then we're back to our old comfy chair again. Give it time. give it time and just look at the values.
Yeah, I totally agree. Let's dive into some cases. Andrew, we haven't talked too much about cases. I know you send a post out into the community about the heater elements, door heaters, door heater thermostat stuff. But I think it's really, really important. There's so many different dynamics of a refrigeration system that we really need to know. And I had a post out on Facebook, I think it was Facebook, where talked about defrost issues and find a wiring diagram, take the wiring diagram, take a look at it. And there were so many people, wiring diagram, there is never a wiring diagram with a case. And I'm like, okay, but I know if I go to Hill Phoenix or if I go to Hussman or if I go to Zero Zone, I can find case manuals very quickly for every one of their cases. Even like if you go to Hussman, you can find all their old discontinued lines manuals of their electrical wiring. So I'm not sure what cases they're looking at. Maybe Arneg, because I know they're a little more difficult to get a manual for. But the ones here that I know about in North America is not too difficult to find cases, wiring diagrams. Do you ever run into a lot of issues finding wiring diagrams for a case, Andrew?
I did. I kind of struggled finding case wire diagrams for the longest time, or if I did, it just took a long time. You know what truly was a game changer of finding any PDF on any case manufacturer? It doesn't matter what it is. You know what's been the biggest game changer for me? AI. AI has been huge on, like, I just talk to it and I say I got a Hussman case and then just spit out the model number. And it's like, oh, here's the PDF. I click it and it pops right up. It is the quickest way to get a PDF now. That's what I use it now for. Partially is AI is using that, and it pops up pops it up right then and there. It tells me the length of defrost, how many times, everything I need. It's great. So yeah, that's how I've been handling it lately, and I recommend it to everyone.
Yeah. And so for the last 12 years, I've been learning how to be resourceful, learning how to research and find. Doing research is not easy. It's something you need to learn. And after you learn it, it's easy. Like for years, I had trouble finding documents, finding wiring diagrams. Now, it almost doesn't matter to manufacturer. I can usually get pretty close to finding what I need to find. It could be through Google, could be from AI, could be from the manufacturer website. But there's sometimes it's hidden deep on the internet. You know what I mean? But a lot of that data is out there. And the big thing is cross-referencing and stuff. And I really learned this from Dixell, because Dixell, they put stuff in one manual that's in a controller that they don't put it in another manual, but that information is in that controller as well. And then they don't just write it in all their manuals. It's like you need to know this stuff. So I learned how to read between the lines a lot of times and say, okay, well, I know this is the manual. This is what this does for this controller. This is a very similar controller. Let me go read that manual and find out if that information is in it. And more times than not, it's in that other manual. And it's just not in that right manual. So sometimes just understanding how to do research for finding wiring diagrams is so important. To find a wiring diagram. And if you can't find it, you need to learn how to draw one out or really understand how wiring diagrams work. Okay. Andrew, do you want to kind of go through this one here? I just pulled a random one up. I think this one might be this is out of a Husband one, but do you want to walk through some of the things that you can check on this to kind of troubleshoot what's going on with the system?
Yeah, I mean, first off is realizing, you got your black wire in and your red wire in, and then you got your white wire in as well, yeah, on your other circuit. So you got to know what exactly those are. So that circuit right where you're circling, that is going to be your 208, 240 volt circuit right there. And then below is going to be your 120. So knowing that is going to be key, because if you go across, let's say those heaters, and you only receive, for some reason, 120, there's probably something going on there, but you need to know what the incoming power is. So definitely knowing what you're supposed to have is going to be key on figuring out what type of electrical issue you may be having at the time. Then going through there, noticing that on the terminal blocks, there's a black line going across it. Those are basically a jumper. So those are all going to be intertwined, connected to each other. So just so you guys if you guys are able to look at it on the top of the terminal block, you'll see that black line. Knowing that, now you know, like all that, what you're arrowing now, that's going to be all black. So that's going to be your 120 side of your 120 volt circuit. And then on the other side where you circled the WT, that's going to be your neutral side of that same circuit. So you going across that, you should receive 120 volts, or roughly about that. Then going through, and then that's where you're going to check. I guess we'll go to that very first one off of 13. It goes to a door frame switch, goes to a transformer, and then back to L1. So that transformer, what does it exactly do? It changes it to DC, so I'm sure it's going to be some sort of light, case lighting, and then that gives it power. So if you're having some lighting issue, the very first thing I would do is just go between 13 and 12 and see if I have 120 volts just right there. If I don't have 120 volts between 13 and 12, that means something's open. And as we can see, there's one of the door frame switch heaters. Hopefully it's not a wire broken in there, but you never know. So it could be a burnt wire or whatever it may be. But that really just, narrows it down. If you have 120, then I'll be going right to the transformer, wherever that transformer is, so the ballast or whatever you want to call it, and then testing that out. If it has power, then it better be putting out 24 volts DC. And if it's not, guess what? Bad transformer.
Yeah. And it depends. It depends on where you're at in the world. We're talking about black and red wires and white. So if you're in Australia or New Zealand or Europe, you may have different colors. So don't let that mix you up, because what you want to understand, when you go to it, because I've traveled, I worked in other countries, you got to go and understand their electrical code. That was one thing I had to go do to back to school and pass when I went to Australia, because their black wire is neutral, where here in Canada, in North America, it is power. So it's your voltage. So just remember, when you're traveling, you want to understand the different country colored codes for electrical wiring. Voltages may be a little bit different as well. 120, 208, 240, 380, 460, 575. Global voltage is different, as well as frequency, 50 hertz and 60 hertz. So we're just kind of, we want to, when you understand the basics of electrical, it doesn't matter where you're at in the world, honestly. But you do need to understand the color coding of those wires, and using your meter is so important.
Yeah, so this is going to be a terminal block. It's going to be sitting on top of the case, or it's going to be down below. And now you don't have to pull out things and pull off anything. It's literally going to be right there in front of you, and that's where you can really start to diagnose. When I first started, though, if I had a problem with the lights, I'd be going directly to the transformer. So I'm pulling off the ends on the frame to find this transformer or whatever. It was like, man, there has to be a better way. Experience, getting taught, training myself, whatever it may be. I don't remember anymore. But then I'm like, wait a minute. Those numbers mean something, and it makes diagnosing any electrical issue in a case in a rack system. It doesn't matter, because you're gonna be able to hopefully find this and go to those points and test it, instead of opening up every single thing and trying to find that exact component.
Yeah.
So that's another.
A lot of times you got to take off the kick plate, maybe, and maybe if it's down below, if it's not above. The thing is, for an example, a good example would be you got a frozen up case. Why is that case frozen up? You want to make sure, is 5 cases on that lineup all frozen up, or is it just one? That makes a difference. If 5 are frozen up versus 1, there's a totally different problem if just one's frozen up. Where would you start if, just say, you have a frozen up cases and you want to check electrically, instead of ripping everything apart after you washed out the case, Andrew? What are some of the things that you would check to see if what the problem could be?
Oh, well, that was a really good saying. Is it the whole lineup, or is it just one case? If it's the whole lineup, I'll be checking what puts this unit into defrost, whatever that may be. Is it a rack controller? I mean, getting older stuff, is it a gain clock? So that's really where I'll be going. It could be a contactor if it's or maybe, it could be anything. I could keep going, but so I would be doing that. If it's just one case, well, then I would be checking the actual pan itself. So I would have to remove at least one of the spots in the product, because I need to know, is it the pan that's frozen, or if it's the coil, just the coil that's frozen. So, I mean, you could check airflow. So you're like, yeah, there's obviously a problem here. Plus, it's temping high, so there's that. But that's where I would start. Once I diagnose, saying that it is a pan that's frozen and the coil, typically the drain has froze up because tags or whatever may have fallen down in there, caused a jam, and then ice starts to build up, and then freezes the coil. So then you got to de-ice the whole thing. That tells the story. However, if it's just the coil, then what puts it in a defrost? And in this case here, we got electric defrost. So I'll be going in, putting this lineup really into defrost, and then I'll be checking my power. And in this case, we got 5 going down to our heaters, our rear and our front heater, and then we go back to 2. So I'll be going 5 to 2, hitting that in with my meter and seeing what type of voltage I have. I should be reading 240 according to this electrical wire diagram. And if I don't, then I got to figure out where does that go. So then that could be in a defrost panel. There's usually a contactor involved. Does the contactor coil have power? Yes. If it does, that contactor should be shut. Is it passing power? So those are the other checks I'll be checking on in this case.
Yeah. And these are some of the things that you can just do with your meter, right? If your power is off, instead of pulling all the pans, trying to find, you got the zip ties onto your heater elements, you can just go to 5 and 2, and then you can see at least go through the 2 of them. Now, if you have an open wiring, like the power's off and you're checking your resistance and it's open, well, we don't know if it's the rear heater or the front heater. Then we got to investigate a little bit further. But if you get resistance through the 2 of them, we know the heater's not broken, for an example. And same thing with the drain heater. In this example, sometimes there's drain heater, sometimes there's not. So we go from 11 to the normally open, because that's where right in that harness, we can check when the power's off, the resistance. Does that drain heater have resistance or not? If it says, oh, well, a good chance this drain heater is probably busted. Maybe it frozen up, and that's why the case frozen up. So these are different things that we need. And there's a lot more things that we can check, and these are just quick electrical checks that you can do if you have a frozen up case.
Yeah, exactly. And the biggest thing here, thinking back when I first started, I'd be going right to those heaters or right to the fans or right to the transformer, whatever it may be. I'd be going directly to that component, but I didn't have to. I was spending more time than needed, and then using this electrical diagram, pulling up and understanding what numbers 1 through 16 is key on speeding up diagnosing and making life a lot easier, because you're not trying to tear apart the whole case, trying to find each individual component.
Man, and I've done that so much, Andrew. I remember like 5 like glass doors. It didn't matter what brand, and a ballast would be out. And I mean, I remember times pulling the whole thing apart, starting in the middle, moving left to right or whatever, and then do it like 6 months later, and then rip the whole thing and breaking things. You know what I mean? Trying to get it apart. Don't know how to take. Not looking up the manual. Couldn't find the manual because didn't have it. Didn't have the internet at the time, and check 4 raceways, and then it's in the 5th raceway. You know what I mean? To find that ballast for the flickering lights or whatnot. And it's so much easier today if you do that 15 minutes of research, a half an hour of research to find the manual of that specific product. And like it says right here, C case plate QR code. So that QR code on a lot of these newer systems, within the last, I say 10 years, 5 to 10 years, there's a lot of QR codes out there. And some of you might be like, what's a QR code? If you have an Android or if you have an iPhone, just go to your photos. So turn your camera on, go to a photo, and just hover around the front of a QR code, and all of a sudden a link's going to pop up, and then you press the link, and it'll take you right to that manual, right to the manual.
Yeah, QR is a square looking, kind of looks like robotic squares, and it's all randomly placed. And like what you said, Trevor, is just put your phone up, put it on the camera, and then kind of just hover right there, and then a pop-up will come up, and it will show a web-based something. You just click that, and then it'll pop right up whatever it's trying to tell you. QR stands for quick reference, just so everyone knows.
Yeah, I love that. Here's an example of a median temperature case. As you can see, there's a lot less to it. You got a frame heater in this one. You got a door frame switch, and you get the fans. So even if you didn't have the wiring diagram, you should be able to draw this out within minutes, not hours. If you look in this raceway compartment, all these components are right here, and you should be able to draw this out. We got how many? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, counting the ground, 10, 11, 12, 13, 14, 15, 16 wires. This is something you can draw. And I recommend doing this. This is really, really important, is drawing this out to give you an idea. Because a lot of times we're looking at this, but looking, doing, and seeing is so, so important. The more I found I got really good at CO2 because I started to draw a lot of the stuff out. PNIDs drew it out. Control diagrams drew it out. It does take a lot longer, but you remember it and retain it so much more when you write it down.
And Trevor, just a quick note. If you could just jump back to the previous diagram. This one here. No, the electrical diagram. Yeah, the freezer thing. From here, it's the same philosophy when you're fault seeking this one as with the gas cooler. You know, take a look, take a step back and look what is actually controlling what. Because in this case here, you start to put on the meter and start measuring the voltage on your heaters. That is really good. If you do have voltage on your heaters, before taking everything apart and start trying to measure if there actually is a faulty heater or something, just think about what is controlling this heater. You have two controlling switches here. You have a defrost thermostat and you have the defrost maximum. I think this was called. I can't remember the name now.
Termination.
The defrost limit. Yeah, the defrost limit. So you have those two temperature switches. And if one of those are failing or just always connected, you will also have an issue here. So it's about taking a step back many times and not just started pulling wires out, but just figuring out what is working and what is not, taking a step back, and what is controlling the things that is actually not working.
Yeah, 100. I totally agree. And once again, there's only so many components in here. If we take a look at it realistically, not counting the wires that could be loose or broken, but we got one come here, the defrost termination. We got a switch, in the frame heater, so that's 2. Then we got the frame heaters, that's 3, and then we got a rear and front heater, that's say 4 and 5. Then we got a defrost limit, that is 6. We got a drain heater, 7. We got a fan, that's 8. We got a relay block, that's 9. We got a transformer, that's 10, and another transformer, that's 11. I don't know.
It's a really simple system. We don't even have controllers and anything in this case here. It's just a purely electromechanical thing, right?
Yeah, and this is just the case that we're talking about, and this is it's pretty straightforward. But this is all cases as well. We're not talking about the case controller at this point, or if it has a case controller. But this, you know what I mean? You will see case controllers on systems like this. You will have another case controller potentially that maybe you get this wiring diagram, but what the manufacturer did has tied all these wires that we see here mechanically tied into a case controller. And now the case controller will do a bit more control versus doing this raceway compartment. So all this stuff, but it's the same thing. So
it's the same logic, yeah, and it's the same approach when you're finding your fault or your fault somewhere. So it's the same approach, figuring out what is connected to what and what is controlling what.
Yeah, and I think that's a great place to end, is because there's only so many components, only so many things that could be at the issue at hand. Once again, there's only so many parts. We got mechanical, we got electricals, we got controls in any refrigeration system, realistically. I think, did I miss anything, Andrew? I think that's basically it, right? So when you understand all of that and you compartmentalize it, and then you take it and you take a look at it just like this, we got 11 potential components, not counting, like I said, the wiring and the power coming in. That could be the issue. And if we go through it, a systematic approach, you're going to find that problem. You're going to figure that out. It's not skipping any steps, though. I think that's where a lot of I get caught when I started out. I would skip a lot of steps, and then I would miss something. I skipped a step, and then I totally missed this relay here. And this relay is the problem that turn the defrost heater on and the fans on. Okay, this is the same thing that's in a controller, only looks a little bit different.
Right.
Awesome, Andrew. Any final thoughts?
Yeah, just to recap is really just invest in yourself. Take that at least 15 minutes. And it doesn't matter if you're staying on the job longer or if you're going home and researching whatever that component may be. Could be a wire diagram. I like what you said as far as drawing it out. That really did help me in my beginning of my career, where I was just learning all of it together. And electrically, it really started to make sense when I started making my own ladder diagrams of a case or whatever it may be. That's where I truly started to fully understand electrical. And I think today, if I had to choose, my strongest asset is going to be electrical. And I think, and I have to credit, what you said there is actually drawing out the ladder diagrams. There's countless number of ladder diagrams floating around that I've done, just by my personally doing that. So I have to credit that for that. So
I love it. Erik, any final thoughts?
No, just what Andrew said. Yeah. Take your time, figure out what's going on about all of this, and figure out what's up and down on your diagrams and on your systems are working. And don't overcomplicate it, and try not to get tunnel vision.
Yeah.
I definitely agree with that, because that can happen quite easily. You know what I mean? In what you're doing. Nikki says, keeping a pocket notebook drawn out keeps records. Been a positive change for me this year. Awesome. I love that, because that's something that I used to write in the logbook diligently. When I first started, I wasn't doing that when I first started, but then I started writing it, because when I went back to that store, I couldn't remember 3 months later what I did. And then having a notepad, I remember so many times I had stacks and stacks of notepads from my pocket, and then I would go back and I'd remember stuff, and important phone numbers, for an example, need to call someone. So it's so key. If you're listening on the podcast, this is part of the Refrigeration Mentor community, refrigerationmentor.com/hub. We're here to help support you in your supermarket and CO2 journey. And as always, Andrew, Erik, thank you so much. Nikki, thank you so much for taking the time to come hang out with us, our Refrigeration Mentor community. I look forward to chatting with you at another one coming up.